Hess's law, right? So for Hess's law, you need to find the HR. So this is the H1. These are all just H's, right? And from these, right, from these equations, you need to find the H1 from that one and the H2 from this one. And you put those two together to find the HR. In this situation, we have an easy question. 2CO gas plus O2 gas goes into 2CO2 gas. Now let's focus on equation 1, and then we can focus on equation 2. So let's focus on equation 1. So as we can see, this carbon right here is unneeded, because if you look, you have carbon monoxide, you have oxygen O2, and then you have 2 carbon dioxide, and nowhere in that equation is there a single carbon. So we can already rule this one out. Now the oxygen is in the correct place on the left side. As you can see, both oxygens are on the left side and both CO2s are on the left side. So for equation 1, there is nothing to be done. You don't have to do anything. Now let's take a gander at equation 2, right? So equation 2 has 2 carbon, which again is unneeded, O2, and then 2 CO. So if you're looking at this, you may see that the CO, the carbon monoxide, is on the wrong side, which means we have to flip it. And when you flip it, nothing happens over here, right? Nothing happens over here when you flip it. Nothing happens in this vicinity when you flip it. But the delta H has to reverse. So in this case, it's negative, so it will reverse to positive. Now, let's just focus on flipping this first. So we'll flip into 2CO gas going into 2C solid plus oxygen 2 gas. So now we have everything in the right spot, right? So, but we have to go back to equation 1, because if we analyze, this is 1 CO2 and this is 2 CO2s. So my mistake, we have to double it. We have to multiply everything by 2, right? So multiply everything by 2, right? So now this is the new, this is the new equation 2, and now we have to write the new equation 1, which would be 2C solid plus 2 O2 gas goes into C2 CO2 gas. Don't mind my handwriting. But also, we need to look at the delta H's. Now I left these for last on purpose, right? So let's focus on this one first. You need to multiply it by 2, because when multiplying just the formula, you have to multiply not only the formula, but everything. So when you do 393.5 times 2, it ends up as 700, right? So now the delta H1 equals 700 negative 787 kJ, and the delta H2 for this one is equal to positive 221.0 kJ, and this is because we flipped the entire equation, which means you also flip the sign, right? So now we have the new equation 1, new equation 2, and we need to now prove that it works. So the 2 carbon, they cross out. You have 1 oxygen and 2 oxygens, so that crosses out. So now you don't have two oxygen anymore, you just have 1. Wait. So now you don't have 1 oxygen anymore, right? You have 2 CO plus O2 goes into 2 CO2. Bang. Right, we figured that out. But what we really want to focus on is this. So let's take this back out. So we have 221 221 minus 787, or you could just add a plus sign, but I did. So in reality, we're just adding these two numbers, which equals HR equals negative 566 kilojoules. So that is our answer. This is our answer. Yes, I know. Very technical. So let's erase all this. So the answer, so let's erase all this. And the answer to the question is this equation equals negative 566 kilojoules. Now, let's move on to the next problem. Last one. Alright, so I'm gonna do one more. The last one was quite easy. It just looked hard. There were 4 equations, but it was quite easy. This one, this one might be a little pain, in the booty to do, but that's no problem. So, as we analyze, we see that N2H4, it's on the wrong side. And then you might be like, oh, but Matthew, the H2 is on the right side. But that's why we have this H2. So, we need to flip it. So, for equation 1, we gotta flip it. So, we flip it, but always remember, when you flip this, you also have to flip the sign on the delta H. So the equation would go to N2. I'm just gonna write N1 like I did before to signify that it's a new equation. New equation 1, right? So N2H4 liquid plus H2 gas goes into 2NH3 gas. Sorry about that H, guys. My writing will get better one day. And then the H1 is equal to negative 22.5 kilojoules. Right, so that's the new equation 1. Now let's analyze equation 2. We have ammonia, I think. We have 2 ammonia gas goes into nitrogen 2 plus H2. Now, if we look, there's no ammonia, so we don't need to worry about that. We just need to worry about the N2 and the H2, which are on the right side of the equation. So the new version of this equation will just stay the same. So this equation, we can check it off, and I'll rewrite it in a bit if we need to. And then the last one, CH2 plus H2 goes into CH4O. As we can see, we need the CH4O and we need the CH2O, and they're both on the wrong sides. So what does that mean? We have to flip it. So new equation 3 is CH4O liquid goes into CH2O gas, because Mr. Red will have a fit if I don't put that, plus hydrogen 2 H2 gas. And then the H3 would be negative 81.2 kilojoules. And then we have this one, which stays the same, and I'm very lazy. So I'm just going to drag it down, make it a little bigger. So, and then this is equation 2. So now you have all the equations, now you need to figure out how to get it like this. So the N2H4, that's good. The CH4O, that's good. But let's look at some things that get in our way. Like the H2, they get rid of each other, right? But we need this one. So this one's good, this one's good. The NH3, get rid of each other. And then you have this, and you're left with these. So, in the end, you do get N2H4 plus CH4O goes into CH2O plus N2 plus 3H2. Right, so that's good. Now we just need to worry about these. So we have to add them all. So it would be negative 22.5 minus 81.2, which equals negative 103.7. And you have to add 57.5, which when you do all of that, when you add them all, you get HR equals negative 46.2 kilojoules. Alright, so that's all for today's video. I gave you guys 3 examples. They were all quite easy, but that is only because these questions are easy when you think about it, right? You can't just go into a question worrying about it. You need to write down what you know, and in the end, questions become easy because you just analyze. You know, you have to become analytical, like Abdel. So, that's all for today's video on Hess's Law.